we start with the first lecture series, which is lecture 01, derivative of a function and notation. The derivative of a function f of x is defined as the instantaneous rate of this function at any given point in time with respect to some other variable. If y is the function expressed as this, we define this as the instantaneous rate of change in y with respect to x. And we define this mathematically as f prime of x is equal to limit of h y upon hx as hx approaches 0 is equal to limit of f of x plus h of x minus f of x all over h of x. H of x approaches 0. We can also use another notation. Either this notation or the one on the board here, f prime of x is equal to limit change in y upon change in x as change in x approaches 0, and it's equal to limit of f of x plus change in x all over change in x is minus f of x, f of x. So this change in x approaches 0. So this notation is the same as this notation, just as we have replaced hx by delta x. Anywhere we have delta x. So this is precisely the definition of the derivative of a function. So it measures the rate at which one function is changing with respect to the other. Now, if the limit of this function exists, it means that the derivative of the function also exists. But if the limit of the function does not exist, it means the derivative of the function does not exist. Now, the process of obtaining the derivative of a function is called differentiation. And at a point x0, if the function can be differentiated, then we say it is differentiable at the point x0. x0 could be any number at all. It could be 3, it could be 4, any number. So it means it is differentiable at that particular point. Now we want to look at different notations. Notations used whenever you are differentiating. First notation is f prime, or let's start with y prime. We also have f prime. We also have dy dx. We have d dx. F of x with another notation. We also have another one d dyx. We also have another one let's so we have y prime with another notation y prime. We also have f prime. Also this is pronounced dy dx. We pronounce this as dy dx. We pronounce this as df of x dx and dyx. These are different notations that we use whenever we want to differentiate a function. For example, if I have y is equal to 3x squared plus 4, and I'm asked to use any of this notation, if I write y prime, this also means 3x squared plus 4 all prime. And we are saying we are differentiating y with respect to 3x squared plus 4. If I also have the second one, dy dx, I can write this as d dx, where y is this function. I can replace y by this function, 3x squared plus 4. It means the same thing. So if I'm differentiating this, it means it is the derivative of this, supposing I use dy of dx. Also, I can write this as f prime of x. We can also say x prime of 3x squared plus 4. Some textbook want to make use of this. So any of the notations we can use to differentiate a function. We can differentiate any function using this particular definition on the board, the first principle definition. So we're going to go into derivative of some function or calculating derivative of a function from first principle. Subscribe to my channel and you watch lecture 02, which is differentiation of a function from first principle. That is calculating the derivative of a function using first principle. Thank you.